Yay. Okay, Gen Chem, we're back. Let's calculate the heck out of some moles. All right, this one's a little bit sassy, isn't it? All right, we're given 2.56 grams of our CH5N. Now that is completely stuck together. That is a molecule. All right, so then we're asked total number of atoms. So let's just give ourselves a little note there that we're asked to count that. So we have to convert to moles, and then we're going to have to convert to molecules, and then we're going to convert to total atoms. This is exactly on your homework. This is that table on your homework that's quite torturous. I can't wait for you to try it. All right, so let's tackle one of these. Let's start with that number that we know. All right, let's convert that grams to moles. So we're repeating again. That's that 31.058. And then I want to keep track that I still have that methylamine is all stuck together. And we haven't broken any bonds yet. And then we're going to convert to molecules, because remember, you still have them all together. So let's take, oh, my bad. Okay, we are going to molecules and moles. Okay, so for every 1 mole, we've got our Avogadro's number. And then are we done there? Are molecules and total atoms the same thing? No. So in every molecule of that CH5N, remember on our table, how many atoms is that? So for every molecule of CH5N, you actually have 1 carbon, 5 hydrogens, and 1 nitrogen. That is 7 total atoms for every molecule. So they're not the same thing. So we need to add an extra step in here. For every one of those molecules, we've got 7. We've got 7 atoms. All right, let's plug that in on our calculator and let's see what we get. All right, 2.56 divided by 31.058 times 6.022 exponent 23 times 7. I am getting 3.474. Can I go ahead and round already? Times 10 to the 23rd total atoms. All right, that's awesome. All right, did you see the difference there? Your molecule, every one of those molecules has all 7 of those atoms in there. So you have to have that ratio in your problem. They are not the same thing. Okay, I love it. All right, let's do another one. Let's get a little sassier. If we were in class, I know you'd be asking for that. Let's get a little sassier. All right, we're going to start doing reactions with these formulas. So exciting. You know, almost always in chemistry, you don't just go get your hands on nitrogen for fertilizer. Okay, this is huge in this country for the last 120 years, agricultural revolution. If you need nitrogen in your soil, you can't just go get nitrogen. You have to go buy ammonium nitrate and use the nitrogen in ammonium nitrate. So we have to calculate and break those bonds up all the time. So this is a really good skill to have, and that's what this question is. How much carbon is actually in that sample of methylamine? Now, don't go Googling methylamine too much. It's actually illegal. So don't go try to buy it. And you would actually be needing it for the nitrogen. So let's actually calculate carbon instead. Let's keep it on the legal side. So if we're going to calculate the amount of just carbon in grams in that sample of methylamine, that's a really pretty common chemistry question. It's quite often that we've got to figure that out, especially in a reaction. You're going to take all of those bonds for that methylamine, and you're going to break them. And then you're going to use that carbon in a different way. So how do we do that? We actually can solve it two different ways. Let's do the long way first. Let's start with our process. We've got 27.5 grams of that methylamine completely stuck together. Let's convert that to moles. Okay, we know that number now, probably by heart. Oh, and then I just goofed it up. Good thing this is on video. All right, and then we are going to figure out, okay, wait a second. That's how many moles of CH5N. How do we get just carbon? We're going to do my favorite thing since sliced bread. We are going to use a mole ratio. Can you do it just by inspection? Probably. But will I write harder problems and try to goof you up? Absolutely. So our mole ratio is literally what's up in orange up in here. It is a math expression. You are going to relate that. Whoa, what happened to my... Oh, I think we're just delayed, y'all. I got a little bit too rowdy there. All right, our mole ratio is how we're going to relate all of the atoms to that total in our CH5N. So that mole ratio of 1 mole of carbon for every 1 mole of CH5N is going to literally turn into one of our unit conversions. So for every 1 mole of CH5N, look, I get to cancel it. It is math. I have 1 mole of those carbon atoms. Okay, that is just carbon. That is how much carbon I have in that total sample. And then how do I convert a mole of carbon to grams of carbon? Well, let's scroll up again and let's take a look at that number. Anybody have a guess already before I get there? What number am I about to use if I want to relate a mole of carbon to grams? Atomic weight. All right, let's scroll down. That's 12.011. Oh, I hope I'm not making you all seasick by scrolling all over. All right, 12.011 grams of carbon in every mole of carbon. Grab your calculator. Let's do this. All right, 27.5 divided by 31.058 times our 12. And what do we get? I get 10.635. Can I go ahead and round already? And that's going to be grams of carbon in that total sample. So anytime you've got 27.5 grams of methylamine, 10.6 of that is carbon. Okay, now isn't there a shortcut to this? If you've seen this before, you're thinking, Dr. Morty, stop making this even harder than what it is. Why can't we just use our mass percent? Oh, here's a shortcut. This is why we give a crap about those percentages. If I've got grams of methylamine and my units are staying the same. Okay, remember I've asked for carbon in grams. I've got the same unit. I want grams of carbon. I can just apply that percentage. Let's go back up and see for every CH5N, how much of that is carbon. Well, let's find our little mass percent here. 38 point, oh, now you can't read it. Okay, let's underline. Let's go with underline or try pink. Okay, so how could we use this number? Well, always 38.67% of that sample will be carbon. So can I take the total and multiply it by that 38.67%? And let's see if our answers are similar, matching. Let's see, 27.6 times 0.3867. Oh, son of a mother, let's go. Look at that. I just got 10.67. Awful darn close. If I round that, I would get 10.7. Now, on a homework or on an exam, could you do either one of these? Absolutely. You could do number 1 or number 2, and look at our answers. They deserve a sparkle pen. They are almost the same. Okay, let's try it then down here. Let's do it again. And let's calculate the amount of, this time, nitrogen in that methylamine. We've got 32.3 grams of total, but we want nitrogen. Let's do grams of nitrogen. So then let's just take our percentage. Let's kind of scroll up for a second. How much nitrogen is in our methylamine? We have 45.10%. Let's do it. And let's see what we get. Grab your calculator. Let's see. I am getting 14.6 grams of nitrogen in every 32.3 grams of that methylamine. Okay, awesome. That's so much fun. Aren't those fun? All right, how do you get super sassy for Gen Chem then? How do we just make these nuts? You know what the worst of the worst is? There's two ways, and they're both in your homework. We throw in percentages, which we just did, only we went forward. We're going to go backward. And then how do you make them really nasty? Your problem goes backwards. Okay, let's do this one in two different ways also, so we can see our percentages and we go backwards. We are given, this time, nitrogen. Okay, now this is as real as it gets. If you're about to go buy something for the nitrogen content, you already have in mind how much nitrogen you need. And then what you have to do is figure out, okay, well, if I need this much nitrogen, how much of what I'm about to buy do I actually need? You can't buy the same amount or you're screwed, right? So let's see if we can figure that out. Let's go backwards. We need 3.67 grams of nitrogen. We're about to buy, oh, okay, don't actually buy it. It's illegal. We're about to buy methylamine, but we already know that we're gonna need more of that methylamine because there's other stuff in it. It's not all nitrogen. We can't go buy 3.67 grams or we're gonna come short. So let's follow our same process. We're given one number, we're given units. We know we need to go from our mass to our moles, and then we can go to our molecules, right? We can go to molecule instead of atoms, and then we can figure out how much we're gonna need. So let's take those grams of nitrogen, let's convert them to moles. Ooh, shoot, anybody remember the number that we need for that? We need the atomic weight of nitrogen. Remember, this is just nitrogen. So we need the atomic weight. Grab your periodic table, or we can scroll up. It's on our table. It is 14.0067. And that's for every mole of nitrogen. Okay, now here's my favorite part. We're going to see this in so many problems. After this, this is our mole ratio. How do we relate our moles between just nitrogen and our methylamine? Well, we need to get rid of nitrogen, and what we want is the full molecule. All right, what was our mole ratio? For every mole of methylamine, how many moles of nitrogen did you have? 5. All right, let's sparkle pen for a second. We need a sparkle pen. The reason I use the mole ratio is it helps you. You probably already see the relationship of 5 to 1, but it also helps you remember if you are about to multiply or divide. One of the most common mistakes on those moles is to multiply when you should have divided, or vice versa. So the mole ratio tells you you only put the 5 in once, and you're going to divide by 5. So it's literally part of our math. I love it. And now we can calculate moles to grams. And what number was that? That was our molecular weight. All right, Let's throw this in on our calculator and then we'll stop with some of these problems. You should be able to tackle that first homework set with some of these, and I hope that was helpful for sure. And then remember, your homework is up on Blackboard and you have unlimited chances on those, so treat them like an answer key. You can do those as many times as you want. Try that problem, plug in your answer on Blackboard and see if you're on the right step or on the right page. All right, 1.63 is what I'm getting for grams. Oh, well, that can't be right, can it? What the heck did I just do? Oh, did I forget to multiply? Okay, hang on. Good thing we're taping this, right? All right, hang on. 3.67. Okay, I'm going to convert to moles. So divided by 14. And then we need to divide that by 5. Okay. And then we're going to multiply by grams. I am getting a crazy number. What is going on, y'all? Is my calculator just not working for me? I'm going from grams, let's double check our units, grams of nitrogen, moles of nitrogen, to moles of methylamine, to grams of methylamine. So let me just double check how I'm putting things in there. It might be I'm borrowing a calculator, so let me just make sure I have the right order of operations. Okay. I am getting 1.63 grams of CH5N. That does not seem right, doesn't it? Don't we need a bigger... Oh, check it out, y'all. This is real life. Look what I did here. Okay, is that right? All right, we may be coming back to this. Let's also try our percentages, because then we know we should be getting the right number. 6.7 grams nitrogen. And what we really want is that methylamine. So we're going to divide by our percentage of nitrogen. That's our 0.4510. Let's see what we get. We'll figure out what went wrong on my calculator on that top one. User error, I guess. Yeah, then I get 8.14 grams. Okay, now that should be the right answer. What in the Sam heck is going wrong up on the top here? Let me try it on my phone. Anybody else getting the 8 grams for that top number? I hope you're screaming at your calculator or at the computer right now. The right answer. This is why we do this in class. All right, let me stop this one.